on the Gulf of Mexico. A demo team chases a new world record.
We cannot take any chances, let's not.
A hurricane-proof tower stands in their way.
We don't have a handle on this structure. We have no way to get the explosives in, no place to put the building. It's going to be a problem.
3 invincible cores.
Does it get better as we go up?
No.
Multi-million-dollar neighbors.
We're going way off the book with this.
It could be a record-shattering drop.
Fire.
Or a world-class disaster. South Padre Island, Texas. Nearly 1 million people hit these beaches every year. More and more want to stay. It may be a developer's dream, but the race to build comes at a price. In this construction frenzy, one site sits abandoned. This is Ocean Tower. Condemned before it was even completed. It was built on a defective foundation and is sinking into the sand. It's a $77 million mistake. Hundreds of metal shores hold the building up. Columns crack under the weight. As the tower sinks into the sandbar, it tilts to the north, threatening homes just 46 meters away. Ocean Tower must be demolished. Controlled Demolition Incorporated has accepted this challenge.
In all the years I've been working with CDI all over the world, I've never seen a structure this well reinforced, this well built.
It could be record-breaking. A reinforced concrete structure this high has never been imploded.
We've got a 33-story traditionally reinforced tower that rises above a parking garage. The tower itself has got one massively reinforced elevator core, and it's got 2 stairwells that are separately reinforced.
The tower's height is a demolition nightmare. There are mansions to the north, a highway to the west, and park facilities to the south. Mark Loiseau, CDI's demolition designer, must drop this 116-meter tower to the east. But he faces a major problem. Even here, the tower is 30 meters too long to land without causing damage. If it comes down at its full height, it will crush these federally protected dunes, or the expensive homes right next to them. To stay in the drop zone, Mark needs to shorten the tower by breaking its spine as it falls. Powerful weather systems are a fact of life here. The structure was engineered to survive hurricane-force winds. Its cores are nearly 7 times thicker than an average residential building's.
If we can't control the elevator shaft, we can't control the building, and we don't have that much room to work with.
The property line to the north lies just 3.5 meters away. Losing control is not an option. Normally, this family business from Phoenix, Maryland, implodes structures because they've passed their prime. Ocean Tower is the newest high-rise CDI has ever dealt with. This time, Mark has to push demolition engineering to its limits.
First, we're going to straighten the tower because there's a bit of a tilt, about 4.5 inches to the north side. So shortening, we're going to straighten the tower up in the delay sequence. Then we're going to tilt the tower to the east. And as the tower tilts, we're going to cut it at different levels. So as it comes over and collapses, the debris pretty much stays within the original footprint of the garage.
The first step, Mark needs to figure out how much rebar reinforces the tower's spine.
There you go.
These core walls are up to 9.5 meters long and more than 3/4 of a meter thick. A skid steer arrives to open them up. But the skid steer can't even penetrate the concrete.
Come look at it. Don't look good, Tom.
And you're not even to the rebar yet.
Not yet.
Look how hard that is. Plan B,
Plan B?
load and shoot. The question is, can Greggy put a hole in it?
We would have to find out.
The rebar configuration remains a mystery. Higher up, a salvage crew strips Ocean Tower's riches. These suites are almost complete. Plumbing installed, bathrooms tiled, and walls ready for paint. Brand new materials built to last for decades. Ripped out before their time. Metal shores, installed to take stress off the failing columns, are exceptionally valuable.
These are salvageable. You know, there's a market for these. We can probably sell them for $300 to $400 a piece.
They'll recycle more than 66,000 tons of material. 85% of what went into the building. On the east side of the tower, the parking garage deals Mark another big challenge. Most of it sits right where he needs to land the tower. But he's not sure if he should remove it. It's a post-tension structure, something the crew doesn't usually come up against. Post-tension beams are made of concrete, but they're also filled with dozens of cables. These are pulled tight and then secured with metal anchors at both ends. This makes the beam stronger. Perfect for a car garage, but potentially disastrous for CDI.
You've got beams here that have almost 2,000 kips. That's 2,000 times 1,000 pounds tensile strength. If we drop the structure on that rubber band that is stretched that tight and it snaps, where does it go?
Thousands of 1.5 kilo anchors could terrorize the neighborhood. Some of these post-tension beams also run under the faulty tower. Demolishing the garage before shot date could send the building into a free fall.
And at that point, the tower would just inexorably move. There's no stopping it.
Mark faces a difficult choice. Leave the garage intact and risk anchors flying, or demolish it and hope the tower doesn't come down early. He needs to learn more about the garage before he makes the call. Back in the tower, Craig Keyes and Tom Dowd try to penetrate the cores. They need to drill past the concrete to the rebar. But like the skid steer, they can't seem to find a way through.
This is where we
try to give you your 5 holes inside the box. You can see how much we had to move the holes.
That's, you know, for the burn, that's all right. But I'd really like to see this all the way through.
Tom's disappointed.
Right at 24 is where you hit the back rebar.
So we'd be lucky to get one all the way through.
Yep.
Even 1.5 inches in that 2-inch hole.
This is bad news.
Does it get better as we go up?
No.
The cores seem impenetrable. But they must be broken, or the tower will overshoot the drop zone. It's an expensive mistake.
I have a federal park. I've got protected dunes with all that planting out there that would cost hundreds of thousands of dollars to replace.
Mark must figure out a way to avoid this eco-disaster, or the aftermath will cost him big time. Mark needs to find a way through Ocean Tower's cores, or this demolition is destined to fail.
The only time we've run up against concrete this hard and reinforcing that is this massive in a structure is in nuclear construction, where we're dealing with structures that are no more than 3 or 4 stories tall. Here we're dealing with a structure that's 33 stories tall.
The reason: this monster tower sits in a hurricane zone. Winds here can reach more than 218 kilometers an hour. So the high-rise is designed to resist annihilation. Now machines are failing to penetrate its hurricane-proof cores. Mark's never had this problem before. He calls in his brother Doug.
I really needed his experience and his expertise. He has far more experience blasting heavily reinforced concrete than I.
They consider an unprecedented plan. Attack the tower's cores with explosives before shot day. Normally, they use test blasts to see how a structure will react to this type of demolition. But they've never tried to reduce the strength of a building with explosives before the implosion. Until now.
We determined that it would be best to modify the cores themselves by pre-blasting holes. So essentially, leaving the cores standing up on legs. Much more efficient to deal with that with explosives.
For the first time ever, CDI will use explosives to attack a structure before shot day. Meanwhile, Mark gets a break. He discovers that post-tension beams at the east end of the parking garage do not run underneath the tower. This means it should be safe to demolish the part that sits in the drop zone. Mark assigns Ray Zakowski.
Post-tensioning is about the hardest thing to wreck conventionally. That tension is about 2 million pounds on every one of those little cables. So as we go in, the multi-processor cracks the concrete and loosens the concrete up. Once it goes slack, it's lost tension, and then we can chew in it and make it come down.
The excavator has to avoid the protected dunes to the east, so the operator works from the south side. He must pulverize almost 2,000 square meters of the garage. As he moves in, he gets closer to these damaged columns and the tower. Doug and Tom get ready to pre-blast the cores. They've never done this before, so they worry about flying debris.
I'm just wondering for the first shot, is this gonna, with neighbors, you think we'd be better off just doing downstairs?
That's why I was thinking.
They load 2 walls with different amounts of dynamite.
We're just kind of playing blind right now until we see the results of this. Usually you can blast concrete with a ½ a pound per cubic yard. Some of these we probably have 10 pounds to the cubic yard. You can't use a rule of thumb loading densities. We're going way off the book with this.
Here's the plan. They've loaded dynamite in a series of circles, each larger than the last. Explosives closest to the center will go off first. Then the explosions will radiate out. This should shatter the concrete and leave 2 legs.
Doug, I'm in the red. Here you go. 5, 4, 3, 2, 1, fire.
Can you see anything?
Oh, we're through.
Oh, yeah.
You're clear, Victor. Come on up.
See, that's beautiful.
Yeah, it is. We're gonna need a couple of brooms and a couple of shovels to clean up this stairwell. I'm good. Here's your burn.
Both shots blasted through the concrete.
There's 5 here, Doug.
There are?
Yep. 1, 2, 3, 4, and 5.
But smaller quantities of dynamite loaded into more holes works best.
You don't need to muscle concrete out. What we need to do is rely on our sequential pattern on how we initiate the delays.
Good news for the loaders. Bad news for the struggling drillers. They'll have to muscle even more holes into the cores.
If you look straight in there, I don't know how they got a hole at all.
And there's another serious concern.
They took that cover down, didn't it? Well,
Yeah, I did.
Debris ripped through the protective covering and shattered Ocean Tower's triple pane windows.
we blasted the hole. I mean, that's great. It did a fine job, but the byproduct wasn't acceptable. That was too much fun.
The neighbors are a stone's throw away. Doug will have to fine-tune the pre-blasting plan. Things are getting ugly in the parking garage.
I got called by one of my employees out here at the parking garage saying that concrete's falling off of the floor slab. This is actually one of the pieces of concrete that are popping out of the slab. You can see where the rebar, the cable, are running through the slab. This would probably be very bad if we get hit on the head with it.
Post-tension cables in the beams are snapping, shattering the concrete. The crew could get their skulls cracked. Everyone has to evacuate. And there's another challenge.
As we pulverize the building, there's still these chunks left hanging on these tendons, which we call widowmakers, because they could fall down and whack you in the head and take you out.
Like Victor's crew, Ray's team can't work in this dangerous environment. If he doesn't find a way to rip out the widowmakers, he'll have to pull the excavators, bringing the project to a halt.
We need to separate this from that before we go that way. As we go this way, it gets really funky. I mean, one bay over from where we're stopping is all that shoring, all those damaged columns. We need to clean this off, get straight through it, release any pull that this thing has on that.
You got two choices, right? My first choice would be to, let's go across the street and get that jaw blade so I can see if I can shear them off.
Yeah.
That next bay, man, as long as it is, we have that spaghetti mess there without cutting and freeing everything.
How long is it going to take you to swap out?
Well, it takes about, say, totally an hour.
All right, I mean, only one way to find out.
And if it doesn't work, you know, I might have to get a torch on it, but I don't want to do that.
No, you know, I'd have to get it. You have to do it with a man lift and get up in there.
It doesn't look fun.
It's not fun.
The operator will try to cut the widowmakers down with a jaw blade. In the tower, the crew hammers out a plan for the cores. They face a difficult trade-off. Smaller quantities of dynamite spread over a larger area works best. But a larger pre-blast area means more loading holes. And usable drill holes are hard to come by. Here's the problem. The cores are reinforced with up to 6 vertical layers of rebar, 3 times the normal amount. And the layers are staggered. It's almost impossible for a driller to get a straight hole through.
The rebar is really beyond anyone's expectations. When you look at the plans, you initially say, why would anyone put this much rebar in this structure?
But there's hope. The team clears out some pre-blasted sites. Now they can finally see the rebar pattern.
Ultimately, I'm going to want the drillers to try to get in here and drill this way.
Craig will try and drill holes between the rebar layers.
By me drilling longitudinally through the wall, I can drill 3 holes and blast just 3 holes compared to blasting 40 holes on the outside edge.
There are 7 shot floors. This longitudinal drilling could save the team thousands of holes. It's a demo marathon. He must push through almost 2 meters of concrete, 4 times the length of a regular hole. Today, he's rewarded.
It went surprisingly well. The rebar is spaced far enough apart to where I can get the longitude holes into it, at least in this wall.
Good.
The drilling is under control, but the weather is not. A violent storm rolls in.
Victor,
Hey,
what floor are you on?
I'm on ground floor. I'm heading up. This does not look good.
It catches the crew off guard.
Yeah, it does not look good, does it?
Victor can't reach workers exposed to the elements on an upper floor.
I'm trying to get a hold of them. They were up on 25. I wanted them to come down.
10-4, I'm gonna head up there now.
Jesse McLeese rushes up to warn them before the storm's fury really hits.
Victor, we have stuff coming off the roof of the building, too. There's chunks of insulation, lots of dust, plastic. There's a lot of debris coming off the roof.
Everyone is evacuated. And the day is lost, with more than 2,000 holes still left to drill. More than 3 weeks pass.
Jim, this
The
leg
crew
here's a new one.
finally gets a break in the weather. Clear, sunny
You leave
skies.
your mask off just for a few minutes.
It
I
won't
already did
last, so they move quickly to drill the upper floors before the storms return.
If you just walk away slowly, they'll release and let you walk. But when you go real quick, when you go over the edge, it stops you from going over the edge.
Jim Masterpole works a half step away from a 60-meter drop. He preps outer columns so the team can load dynamite. His drill weighs 45 kilos.
60 miles an hour up here, you can't stand on the edge. It'll just take you right off. It's crazy up here. I've been doing this 10 years and still a little bit of pee comes out whenever I have to get on the edge like this.
The pre-blasting and drilling show Mark how strong Ocean Tower is. He worries the 3 cores won't come down on shot day. The building could shear away from the hurricane-proof spot. Mark has to up his game, or this demolition could turn into a record-breaking disaster. Doug and Tom are ready to pre-blast more core walls. This demo project marks the first time they've ever used explosives to reduce a building's strength before shot day. So they're still trying to get the formula down.
What we're going to do is adjust the loading density, cut the amount of explosives we're putting down per hole, so we can try to keep the concrete from flying where it could impact the adjacent properties.
They're loading smaller quantities of dynamite into more holes, so they must also fine-tune the initiation system.
Why don't I put a 475 here? You start everything at 300 upstairs.
Because the 300 is going to go up before the 475 is.
No, the 475 is going to initiate the cord. We're going to go electric to 475 to cord.
Yeah.
Upstairs, just electric.
Oh, okay. I mean, to split these.
They work out a plan.
Put a half a second between.
Victor, you clear? All right, we're good. Tom, warm up the machine. Tell me when you're warmed up.
Traffic's good, we're clear. In the red.
5, 4, 3, 2, 1, fire. Less explosives, more holes, better results. Look at that. That's the ticket.
Success. The system works.
That cleaned it out nicely.
They've mastered the pre-blasting. But elsewhere, a huge setback. Craig thought he could drill Ocean Tower's cores longitudinally. But after weeks of work, he fails to sink the required holes.
There's a lot of rebar in this wall where it's not supposed to be.
It's so bad that he can't get a single longitudinal hole into the elevator shaft. The cores defy one of CDI's best.
I'm afraid we're resigned to spot drilling the elevator shaft just because the steel is too tight. He's not going to be able to get a hole in there.
CDI's demolition designer must up his strategy. Mark also worries that the rebar-dense cores will defy him on shot day. He decides that a complex network of high-tensile steel may do the trick.
Mark came up with the cabling plan, gave us the drawings, emailed them last night. So now I have to go, discuss it in principle in the building. Grab there, down. We're gonna grab here, down, and we're gonna grab there, down.
Yeah.
But the crew have never seen anything like this. 852 meters of cable, connecting cores and columns to one another on 5 of the tower's floors. The cable is 3 times stronger than the kind they normally use because it's never had to work this hard.
The cables connect the elevator core to the stair cores and then into the columns out in the direction of fall. As we move through the building, those cables will sequentially go into tension, creating rotational moment that will pull the tower over toward the Gulf of Mexico.
Craig hustles to finish the extra work.
It's from ceiling to floor. We just try to grab the top of the column and the bottom of the column through the floor slabs so that the floor slabs help so nothing slides up and down the columns as the building's moving. What we have for tools is just a chain come along and a sledgehammer. The fun day, the cable right there.
The cabling's done. Tom starts to load dynamite into the cores. He doesn't usually work with a tape measure. On most demo sites, CDI uses bags filled with sand to space out dynamite. It's called deck loading, and it makes explosives more efficient. But that won't work in these rebar-infested walls.
If you're trying to push a bag in and you catch a piece of that rebar and that bag bridges, you've now lost that hole. And with a structure this size, we don't want to lose a single hole.
The solution? Air deck loading. Tom calculates the optimal distance between sticks of dynamite and uses a tape measure to position the explosives. This way, he gets the benefit of deck loading without the risk. At the base of the tower, Doug calculates another crucial load.
The column I'm loading now is a big controlling column. There are 4 columns that are probably the most important in the building that we have to crack to allow it to bend and then eliminate completely. For each hole, I'll calculate how many cubic yards or percentage of a cubic yard each hole takes care of. And from, 35 years of experience, I know how much explosive it takes per cubic yard of this real brittle, high-density concrete.
Bad weather continues to plague the crew. Dangerous winds often confine them to the lower floors. But they can't delay anymore. Someone has to load columns on 4 of the upper floors. Once again, it's Jim's lucky day. The height's still gut-wrenching. But this time, there's no sunshine to comfort him. The change in weather pushes him to the edge. He's got a long way to go. 39 exposed columns still to load. CDI's wiring guru arrives on site, and she doesn't catch a break either. Every column and core the team has loaded needs to be wired. Stacy Loiseau and her sister Devin are forced to brave the windy upper floors.
Jeez. Gotta lean into it here. I'd love to wait for this storm to pass and be able to do this tomorrow, but unfortunately the clock's ticking. We need to get this done today. We'll tough it out. Seriously, this is just sort of blowing around. It's a tangled mess.
And the wiring has never been this complicated.
The problem is the stairwells are sort of a mix and match between longitudinal drilling and spot drilling. And when wiring them, we have to treat them very differently.
Her crew must run 2 initiation lines, one for the regular holes and one for the longitudinal holes.
We can't let these 2 lines touch. They're on 2 totally different times. If these two lines were actually to come into contact with each other, basically you could have an entire core going off either 5 seconds too early or 5 seconds too late, which would be unbelievably bad.
The tower would fall uncontrollably, putting the neighbors at risk.
So it's a constant challenge to check, double check, recheck that these cannot possibly touch each other. And think about it, Ray. Think about how often we run cord across little concrete. I mean,
Right. But if we put a big piece on it, why take the chance?
No, that's fine. I don't think you need to. I think you do need to soften this.
Yeah, so I'm going to just cut a piece of fabric and just lay it in.
I think that's a good plan. We've got to get all these lines weighted down to my satisfaction, really, which is basically weighting it down every 3 or 4 feet. It's very time consuming. They don't call me the Martha Stewart of demolition for nothing.
Crews have finished demolishing the east side of the parking garage. What's left of the structure is now safe for workers. Victor's crew hustles to make up lost time.
Run. Now is when you need to run.
Upstairs, Ray checks the team's cabling job.
35,000 pounds is breaking strength. It'll do much more than that. You could pick up a tank with this stuff without any difficulty at all.
But will these cables be enough to pull the tower's cores? We'll find out firsthand.
The mission is to get unprecedented shots of the implosion of this tower. So what we've gone ahead and done is planted 12 cameras strategically placed throughout the tower between the 24th and the roof. All this stuff is going to 2 different boxes. We got custom-made iron cages to protect the footage for the trip down.
It's shot day. Stacy and her crew finish wiring the tower. They've laid more than 4 kilometers of detonation cord.
This is where I need you. Got the weight of this?
No, it's not heavy at all.
No, but I just need you someone to hold it.
Oh, I mean, it's
I just
heavy.
need someone to hold it.
Now, we need to get the weight off underneath this.
It can hold it for a minute or 2.
Really?
Yes.
If we can not take any chances, let's not.
No.
CDI walks the building to triple check thousands of connections.
Hey, Ray and Devin, also keep an eye out on your deck-loaded columns. Be sure the green cord is tucked in.
When we blast, we're going to find out real fast if we're right or wrong. You know, we'll either be heroes or bums.
Police block off a 600-meter exclusion zone. Thousands gather to see a world record attempt to drop this tower. CDI takes their positions. Here's what they'll watch for. The team demolished part of the parking garage, so the high-rise has a place to land. If they didn't remove enough, post-tensioning anchors could shoot out. Tom and Doug pre-blasted Ocean Tower's hurricane-proof cores. But they could still be strong enough to resist implosion. Stacy rigged a complex dual wiring system to shoot the cores at the perfect time. If the det cord crosses, mansions to the north could be destroyed as the building falls uncontrollably.
Mark, we're in the red.
Here we go. 10,
9, 8, 7.
5.
Fire.
This could be the highest reinforced concrete structure ever imploded. Ocean Tower comes down in 13 seconds.
It's on the ground, Victor.
Tom Dowd, report from your side.
Got a lot of dust, Mark. I'm starting to work my way in now.
From a distance, the high-rise appears to have toppled completely. Tom approaches the site. Mark waits for a report.
Turn the side of the graph. Collect the side of the graph, Ray.
I'm still coming in, Mark. Holy sh**.
Debris lies on the wrong side of the fence. Here's how it all happened.
Fire.
The pulse reaches the building. Columns on the east end of the garage detonate first. Explosives in the upper levels go off. Anchors do not shoot out as the tower falls. The outer part of the structure begins to fold. The high-rise doesn't tilt as much as Mark hoped. Some cables pull. Others snap. The cores hesitate. But Stacy's wiring system comes through. The spines fail and break up. To the east, the tower lands in the drop zone. In this unprecedented footage, we get a chance to ride this monster tower as it crashes to the ground. one of the cores doesn't fall as planned. The top 5 floors of a stairwell core rolls off the debris pile and comes to rest outside the northern perimeter. They explore the site. Relief.
Something here.
The debris sits only 1.5 meters beyond the perimeter.
We are all clear on the houses to the north. Mark Lawaza, you copy that?
None of the $1 million homes are damaged, but a section of fence is crushed.
Those shafts are just so rigid, so tough. It just rode over, and then it rolled off to the side.
Crews quickly mobilized to clean up. Everything else went as planned.
I wish I could have gotten it to move maybe another 10, 15 feet initially, then we got it, and maybe we wouldn't have this little problem on the north side. But the plan is good. To be able to have that energy at your disposal and use it effectively, it has to make you smile. It has to make your day.
The mission to drop the highest reinforced concrete structure ever is a success. CDI will submit this project to the Guinness Book of World Records. Ocean Tower, an engineering disaster many would rather forget. But in the wake of its destruction, the mission to build on this sandbar will surely continue.